In this lesson, we're going to be looking at how we can use two-way tables to help organize our data and help us find probabilities. Oops. So first, what is a two-way table? You basically see one right here. It, in essence, just takes one group and you take out basically two pieces of information from it. So you have two categories that we kind of combine to create this two-way table. So the definition is a frequency table that displays data collected from one source, and that's important because we want to take information from one group, right? One cohesive group that belong to two different categories. The categories are basically these titles here. So for example, in this example, attendance and class, these are your categories. And because it's a two-way table, you would have two possible results or two possible responses to each category. So attendance, you have either attending or not attending. Class, you've got two categories or two possible responses there, freshman or sophomore. Okay. Now, the four data points inside your two-way table are what we call joint frequencies. So again, it's just a fancy word for saying data entry in the table. Okay, so just again, fancy way of saying these are the data points. So you have 25 freshmen who are attending class, you have 30 or 80 sophomores who are attending class. So joint because it takes into account both categories, and frequency meaning how many times it happens, right? So again, you don't just have 25 freshmen, but you have 25 freshmen who are also attending. So again, it has two characteristics there. And the marginal frequency are basically the sums of your rows and columns. So your marginal frequencies are basically your totals. So we can just add that extra row, add that extra column, and it's going to actually give you 5 extra slots for information. So all you're going to do is basically add them up. So 25 plus 80, this would be 105. 44 plus 32, this is 76, right? 44 plus 25 is 69. 80 plus 32 is 112. Now this last corner here, this final total, should be a checkpoint because if you add 69 and 112, we should get the same thing as 105 plus 76, which is 181. And this little corner tells you the total, overall total, your total responses. Right? So in total, you talk to 181 freshmen and sophomores to get this two-way table data. That's what that means. Okay? So you want to be able to organize your data in a two-way table as a way to kind of help you see what we have. Interpreting just means do you make sure you know what each number means. So we'll kind of ease our way into using our two-way tables by looking at example 1. Okay, so in example 1, there are 16 juniors and 24 seniors on a debate team. Of these, 7 juniors and 19 seniors qualify for a state debate competition. We want to make a two-way table. The very, very first thing you should do is identify your categories. So think about what information do we know and how is it sorted? So I might see, okay, there's juniors and seniors. So maybe I should have a category for class. So class meaning what, class level you're in. So I have juniors and I have seniors. But then there should be another set of information, right? So what are these juniors and seniors doing? Well, if you look, hey, they're qualifying for a debate competition. So maybe that should be my second category, right? So they qualify either yes or no. So that would be my two-way table. All right. So I'm going to find this first, and then we can go through and figure out your marginal frequencies. So just look at the information. There are 16 juniors and 24 seniors. Okay. So that gives me some totals. So actually that means maybe I should add in my marginal frequencies here. All right, there you go. So if there's a total of 16 juniors, then I'm going to put 16 for total juniors, 24 seniors, so 24 total seniors. Of these, 7 juniors and 19 seniors qualify for a state debate competition. So where do you think the 7 is going to go? Well, if they qualified, that would mean yes, right? So juniors, yes, who qualified, 7. 19 seniors qualified. So seniors, yes, who qualified? 19. Then we can go ahead and figure out the rest of that information by simply adding and subtracting. So we know that there's a total of 7 plus 19. There should be a total of 26 students who qualified, right? 16 minus 7 gives me the number of juniors who didn't qualify, so that should be 9. 24 minus 19 gives me the number of seniors who didn't qualify, so that should be 5. Adding up 9 and 5, oops, there we go, oops. Okay, 9 plus 5 gives me 14, so that's 14 total non-qualifiers, and then just double check your actual total responses. So 26 plus 14 gives me 40. Does 16 plus 24 also give me 40? Yes, so I'm pretty confident that's my two-way table. Interpreting the marginal frequencies just means take your totals and tell me what they mean. So obviously we know 16 and 24 because that was given. So let's look at the three red numbers on the right margin. So 26 represents what? 14, oops, represents what, right? And then finally, what does the 40 represent? So if you just go by the rows, right, 26 are the total people who qualified, juniors and seniors who qualified. 14, the number of juniors and seniors who didn't qualify. And 40 should be the total number of people on that debate team. Okay? Last thing we're going to do in the video today, talk about relative and conditional relative frequencies. And these are basically where probability comes in. So joint relative frequency is basically the probability of an event happening in the two-way table. So it's the frequency, right, the number in your two-way table, over the total value, which is that number in that lower right-hand corner. So this is basically probability. And probably closer to experimental probability than theoretical sometimes because of just the data we're given. But anyway, so probability, frequency over total value is basically occurrences over total, right? Marginal relative frequency is marginal, think adding, right? When we did marginal frequency, we were finding totals. Marginal relative frequency is basically the same thing. It's the sum of your joint relative frequencies. Okay, so again, it's just summing up your rows and columns. Finally, conditional relative frequency is basically conditional probability. How do we find that in our two-way table? It's basically the ratio of your joint relative frequency, which is again the probability of each number in your two-way table, right, over the marginal relative frequency. And it's basically the row or column total that corresponds to that joint relative frequency. And we'll look at that in class, okay? One last example, and then we will wrap up this video. Example 2, we're going to use the debate information from example 1 to make a two-way table that shows joint and marginal relative frequencies. So when you think relative frequency, again, we want to think probability. So what we want to do is we want to go back and look at that table for the debate, and you're basically going to figure out what was the probability of a junior who said yes, right? What's the probability of a senior who said yes, or who qualified yes? So that's what we're going to do. So the probability of juniors and yes, actually, let me just do this here. So juniors who made it, 7 over the total, 40. Rounding to the nearest hundredth, we're going to get, or let's actually, this goes evenly, so this will be 0.175. Juniors who didn't make it, 9 out of 40, and that's going to equal 0.235. Or actually, I can't read my own handwriting. That's 0.225. Then we had seniors who made it. So that'll be 19 out of a total of 40 students. That's going to give us 0.475. Oops. And then the seniors who didn't make it. That's 5 out of 40. Again, we're looking at the overall total number of students to create our joint relative frequencies. So that's 0.125. So I can put this together into a table, just basically copying over what we had in example 1 as my labels. All right, there you go. I'm adding in the total because if you look in the directions, I'm also asked to find marginal relative frequencies, and I know marginal means adding up those totals. So I'm going to go ahead and fill in my decimals in my table. So 0.175 are juniors who yes made it, 0.475 seniors who made it, 0.225 juniors who sadly didn't make it, and 0.125 were the seniors who sadly didn't make it, right? Then we're just going to find the marginal frequencies by adding up those decimals, and hopefully you see something interesting happening here. So if we add these up, we get 0.65, 0.225 plus 0.125 gives me 0.35. Coming down, I get 0.6, and coming down, we get 0.4. Now, when you add these all up, what do you notice they all add up to? They should add up to 1, right? Because the total probability is 100%. So if you're talking to any one of these people, you should get either a junior or senior who either qualified or didn't qualify. Okay? So that is it. We'll talk about conditional relative frequency and conditional probability in class. Please come back with questions. Don't let the vocabulary trip you up, right? Joint relative frequency, marginal frequency, all that. It's just words that represent data, sum, probability. Okay? Thanks for listening.